Dear students, let us continue our discussion on complex numbers. Before I discuss level 2 problems, let me explain a few concepts which you haven't learned before. See, suppose if I have mod z minus z naught is equal to r. So when I write the modulus of z minus z naught, here z is any complex number, it's a variable. Z I can treat that as x plus I and z naught is a fixed complex number. Then this equation z minus z naught modulus of z minus z naught equal to r represents a circle with center at z naught and radius r. Let me explain how it is. I take z is equal to x plus I y, a variable complex number which means x and y can take any values, and z naught is a fixed complex number, let it be x naught plus I y. Then modulus of z minus z naught means x plus I y minus of z naught. Z naught is x naught plus I y naught. That's equal to r. Okay. So now I can write this as x minus x naught plus I into y minus y naught is equal to r. I want the modulus of this. Modulus of x plus I y is square root of x square plus y square. So the modulus of this complex number is root of x minus x naught whole square plus y minus y naught whole square is equal to r. Now I will square this equation. When I square this, I am going to get x minus x naught whole square plus y minus y naught whole square is equal to r square. Okay? You can compare this equation with x minus h whole square plus y minus k whole square is equal to r square. This is a well-known equation for you. This represents a circle with the center at h comma k, and radius r. Right? Therefore, this equation represents a circle with the center at x naught, y naught, and radius r. So remember, mod z minus z naught equal to r represents a circle with the center at z naught and radius r. Okay. Then I take one example. Suppose if I have modulus of z minus of 2 plus 3i is equal to 5. Okay. So this equation is of the form mod of z minus z naught is equal to r. Now I will explain how this represents a circle. Z I will take it as x plus I y as usual. Minus of 2 plus 3i is equal to 5. So we can write this as x minus 2 plus I into y minus 3. Modulus of that equal to 5. Modulus of this complex number is nothing but square root of x minus 2 whole square plus y minus 3 whole square. That's equal to 5. Squaring this equation, we get x minus 2 whole square plus y minus 3 whole square equal to 5 square. As you can see, this represents a circle with the center at 2, 3 and radius 5. We are very well aware that x minus h whole square plus y minus k whole square r square represents a circle with the center at h, k and radius r. So this represents a circle with the center at 2, 3 and radius 5. So now coming to this, actually without doing all these things, just by looking at this equation only you can identify. Observe 2 plus 3i. 2 plus 3i is a complex number which when represented on the Cartesian plane or the Argand plane, this complex number is represented by the point 2, 3. So if I compare with this, z naught is 2 plus 3i which is represented by by the point 2, 3 and r is 5. So this represents a circle with the center at 2, 3 and radius 5. So remember this formula, it will be useful. Okay. Then suppose if you have modulus of z minus z1 divided by z minus z2 is equal to k, then this represents a circle if k not equal to 1 and represents a straight line, or in particular this represents the perpendicular bisector of the Z1 and Z2, perpendicular bisector of the line joining Z1 and Z2 when k is equal to 1. If this k is equal to 1, it represents the perpendicular bisector of the line joining Z1 and Z2. And whenever k is not equal to 1, this represents a circle. Here Z is a variable complex number which usually we take it as x plus iy. Z1 and Z2, they are two fixed complex numbers. I will explain with the help of one example. Let me take Z1 is equal to 1. 1 means, and it is nothing but 1 plus I into 0. And Z2, let it be equal to minus 1. That is minus 1 plus I into 0. Okay. So then I will write modulus of Z minus 1 divided by Z plus 1 is equal to 1. We will take. Okay. Mod of Z minus 1 divided by Z plus 1 is equal to 1. According to this, say, here I told you that it represents a perpendicular bisector of the line joining Z1 and Z2 whenever k is equal to 1. In the example what I have taken here, k is equal to 1. So now this represents the perpendicular bisector of the line joining Z1 and Z2. How does it represent? Or before we go there, let us say what is the perpendicular bisector of these two. Okay, these are our plotted axis, x and y axis. Z1 is the complex number 1 plus I into 0. 1 plus I into 0 is represented on the plane by the point 1, 0. This is 1, 0. Then minus 1 plus I into 0, that is represented by the point minus 1, 0, which lies on negative x-axis. Now I want the perpendicular bisector of the line joining these two. Perpendicular bisector means it should pass through the midpoint of the line joining given 2 points and it should be perpendicular. As the word says, perpendicular bisector. Perpendicular means it should be perpendicular to that line, whatever the line we find, that should be perpendicular to the line joining these 2 points. And bisector, as the word suggests, divides it into 2 equal parts. So the perpendicular bisector of the line joining these 2 points, let me call them as P and Q. Perpendicular bisector of PQ is nothing but y-axis itself. As we can observe, y-axis passes through the midpoint of these two. Midpoint of these two, midpoint of 1, 0 and minus 1, 0 is the origin 0, 0. And that line is perpendicular. This line is nothing but x-axis only, and y-axis is the perpendicular to this. So y-axis will act as the perpendicular bisector of the line joining P and Q. Okay. So that we know through geometry. Now I will explain that through complex numbers. Okay. Say mod z minus 1 by z plus 1 is equal to 1. Z I will take it as x plus iy. So x plus iy minus 1 divided by mod of x plus iy plus 1 is equal to 1. I will cross multiply here. I can write this as modulus of x minus 1 plus iy is equal to modulus of x plus 1 plus iy. Now I want the modulus of this, which is square root of x minus 1 whole square plus y square, that is equal to square root of x plus 1 whole square plus y square. Squaring this, we get x minus 1 whole square plus y square equal to x plus 1 whole square plus y square. This y square we can cancel. If I expand this, I am going to get x square minus 2x plus 1, and on RHS x square plus 2x plus 1. So x square gets cancelled, 1 also gets cancelled. We are left with minus 2x equal to 2x. In other words, that implies 4x is equal to 0. 4x equal to 0 will imply that x is equal to 0. So this represents the line x is equal to 0. Now x equal to 0, what does this represent? X equal to 0 is nothing but it is the equation of y-axis. X equal to 0 is the equation of y-axis. Already I have told you that the line perpendicular bisector of the line joining PQ is nothing but y-axis. That y-axis, its equation is x is equal to 0. So students, now when you might get a question like this, The question is, this represents, and the options may be. So what does this represent? That question, which is mod z minus 1 by z plus 1 is equal to 1. Represents, options may be straight line, circle, parabola, ellipse. So if these options are there, then you know that mod z minus z1 by z minus z2 is equal to k, when k is equal to 1, represents the perpendicular bisector of the line joining z1 and z2 whenever k is equal to 1. Okay? And we also know perpendicular bisector is nothing but a straight line only. So if such options are there, then your answer must be straight line. But if the options are, so first option is straight line, second option is x-axis, third option is y-axis, fourth option is straight line, not passing through the origin. Straight line, not passing through the origin. Okay. See, question is same, but the options are different. With the earlier set of options where the question is mod z minus 1 by z plus 1 is equal to 1 represents. What does it represent? That's the question. In the earlier case, we had the options as straight line, circle, parabola, ellipse. Among them, straight line is the answer. But now the options are specific. See, what does this represent? Straight line is a more general answer. It's not a specific answer. With the previous set of options, straight line is the correct answer. But with the current set of options, straight line may not be the most appropriate answer. See, now among these options, the most appropriate answer is y-axis. Because when I say straight line, of course it is true that it represents a straight line, but this is a more specific answer. Straight line means y-axis is one of the straight lines, but it doesn't mean that all the straight lines are representing y-axis. So this is a more specific answer. Now this option must be the answer. And this is certainly not true. And straight line not passing through the origin. Obviously it is not true, because what we are answering now, we are taking y-axis, which is a straight line passing through the origin. Okay? But if that option is also there, say instead of this, if we have straight line passing through the origin here, then also y-axis is the answer, because you can have infinitely many straight lines which are not passing through the origin, but there will be only one line, that is y-axis. That is the perpendicular bisector of this. Okay. Then if instead of k is equal to 1, if k is not equal to 1, then it represents a circle I told you. So let me take the same example. Here instead of 1 I will write 2 here. Okay. K is equal to 2. Then what happens? Here you will have 2 and here you will have 2, and now square it, you will have 4 here. Okay. Then I will simplify. On LHS we have x square minus 2x plus 1 plus y square. On RHS we have 4 into x square plus 2x plus 1 plus y square. Okay. Then x square plus y square minus 2x plus 1 is equal to 4x square plus 4y square plus 8x plus 2. Now take all of these to RHS. We get 3x square plus 3y square plus 10x plus 3 is equal to 0. Okay? I am taking them to RHS, and after simplification this is what we get. Now I divide this equation by 3. That will give you x square plus y square plus 10 by 3x plus 1 is equal to 0. Now you can compare this with x square plus y square plus 2gx plus 2fy plus 3 is equal to 0. This is of the form x square plus y square plus 2gx plus 2fy plus 3 is equal to 0. So we can say that this represents a circle. Okay. Next, I will explain one more concept before we go to problems. Now, is representing a complex number z. Let P is a point which represents a complex number z. Okay. Now, this point P is rotated through an angle theta in the anti-clockwise direction. This is the clockwise direction. Now I am talking about anti-clockwise direction. This point is rotated through an angle theta. Okay, through an angle theta in the anti-clockwise direction. And that point, let us say, it reaches Q. See, this length remains the same. This length, this line OP we have, it is rotated through an angle theta so as to reach Q. Okay, in the anti-clockwise direction. Then this, we know this point is this point represents the complex number z. Then this point Q, that represents the complex number z into cis theta. Okay. If this point P is rotated through an angle theta in the anti-clockwise direction, then the new point that represents the new position, this point represents the complex number z into cis theta. That is, if you are rotating through the anti-clockwise direction. Suppose if you are rotating through the clockwise direction, then the new point, so let us say this angle is also theta, but rotated through the clockwise direction. Then this point, let me take as R, it is represented by z into cis of minus theta. It indicates minus theta because we have taken the angle we have rotated through the clockwise direction. Therefore, negative sign is considered. Okay. So is clear? Let me explain again. P is a point which represents the complex number z. Then that point P is rotated through an angle theta in the anti-clockwise direction so as to reach the point Q. Then that Q represents the complex number z into cis theta. Okay. Then suppose A is a point which represents the complex number z1 and B is another point which represents the complex number z. Then the point which divides the line joining AB internally in the ratio m:n is given by mz2 plus nz1 divided by m plus 1. Just like the section formula, mx2 plus mx1 by m plus n. It's very similar to that. Okay. mz2 plus nz1 by m plus n. This represents a complex number which divides the line joining A and B internally in the ratio m:n. If it is external division, we go for mz2 minus nz1 divided by m minus n. Okay. Then you will get problems like 4 points are given, 4 complex numbers are given, z1, z2, z3, z4. Then the question is, what do they represent? Do they represent do they form a square, or do they form a rectangle, or rhombus, or a parallelogram, etc.? Then what we do? We will take all those complex numbers. They are representing some points, right? So you denote them as A, B, C, and D. 4 points, you know, and use distance formula. Okay, if all the 4 sides are equal, then diagonals are also equal. Then it becomes a square, and so on. That, you know, by using distance formula, you can verify that. And then further, if okay, so this is the section formula we have. From there, we can obtain the midpoint formula also. Say midpoint of the line joining z1 and z2 is given by z1 plus z2 divided by 2. Just like in our 2-dimensional geometry, x1 plus x2 by 2, y1 plus y2 by 2 we have. So here z1 plus z2 by 2. So now suppose if you have a parallelogram, let me consider a parallelogram here, where these 4 vertices PQRS, they are representing the complex numbers z1, z2, z3 and z4. Then The condition for them to represent a parallelogram. You know, in a parallelogram, the diagonals bisect each other. Diagonals bisect each other means the midpoint of the diagonal PR is same as the midpoint of the diagonal SQ. So midpoint of PR is nothing but Z1 plus Z3 by 2. That is equal to, because in a parallelogram the diagonals bisect each other. Midpoint of PR must be equal to midpoint of QS. So that will be equal to Z2 plus Z4 by 2. 2 gets cancelled, and so get Z1 plus Z3 is equal to Z2 plus Z4. This is the condition for these four complex numbers Z1, Z2, Z3, Z4 to represent a parallelogram. Okay, students, with this, now let us go to level 2 problems. Question number 50. Okay. See here we have, if modulus of 3z minus 2 is equal to 5, then the locus of z is 3z minus 2 is equal to 5. Then what is the locus of z? I take 3 as a common factor. Here we get 3 into z minus 2 by 3. 3 into z minus 2 by 3 is equal to 5. This 3 you can take out. It will become mod 3. Mod 3 is 3 itself. 3 into modulus of z minus 2 by 3 is equal to 5. Or I can write that mod of z minus 2 by 3 is equal to 5 by 3. Modulus of z minus 2 by 3 is equal to 5 by 3. You can compare this with mod z minus z naught is equal to r. Mod z minus z naught equal to r. Here I told you it represents a circle with the center at z naught and the radius r. So this represents a circle with center at z naught. Z naught means 2 by 3 comma 0 and radius 5 by 3. Okay. So represents a circle with center at 2 by 3 comma 0 and radius 5 by 3. We get x minus h whole square, which is 2 by 3 whole square, plus y minus k whole square, y minus k whole square is equal to r square, 5 by 3 whole square. We need to simplify this. X square plus 4 by 9 minus 4x by 3 plus y square is equal to 25 by 9. So x square plus y square minus 4x by 3, 4 by 9 minus 25 by 9, that will give you minus 21 by 9 equal to 0. Now I will multiply this equation by 9. When I multiply by 9, I am getting 9x square plus 9y square minus, here 3 gets cancelled, so you get 12x minus, in this case 9 gets cancelled, so minus 21 equal to 0. 9x square plus 9y square minus 12x minus 21 equal to 0, which is the second option. Okay, now let's go to the next question. The equation mod z minus 1 whole square plus z plus 1 whole square is equal to 2. What does this represent? Let us simplify. Mod z minus 1 whole square. Z I write as x plus iy minus 1 whole square plus x plus iy plus 1 whole square is equal to 2. So I can write this as x minus 1 plus iy whole square plus x plus 1 plus iy whole square is equal to 2. So modulus of x plus iy is root of x square plus y square. So here you get root of x minus 1 whole square plus y square. But whole square, so that root gets cancelled. You get x minus 1 whole square plus y square plus, this will give you x plus 1 whole square plus y square is equal to 2. Expand this. Here when I add these two, this is a plus b whole square, this is a minus b whole square. A plus b whole square plus a minus b whole square will give you 2 into a square plus b square. So 2 into x square plus 1 plus 2y square is equal to 2. So you get 2x square plus 2 plus 2y square equal to 2. 2 gets cancelled. You can divide by 2. You get x square plus y square is equal to 0. X square plus y square is equal to 0. You observe, both are squares here. Their sum is equal to 0. It is possible only when both are equal to 0. Because among these two, if one of them is non-zero, then their sum must be positive. Right? So it is equal to 0 means both should be equal to 0. So x is 0, y is 0, which means it represents the order pair 0, 0. Let's look at the next question now. If the real part of z square is equal to 2 into real part of z plus 1, then the locus of z is real part of z square. Z, we always take it as x plus I, right? Now I want z square, which means x plus IY whole square. Expand this, x square plus I square y square, then you minus y square plus 2ix square. Okay, this is x square. Then z plus 1 is x plus 1 plus x plus IY plus 1, and writing as x plus 1 plus I. We want real part of z square. This is x square. Its real part is x square minus y square. Imaginary part is 2x. We want real part of z square, that is x square minus y square. That's equal to 2 into real part of z plus 1. Real part of z plus 1. Z plus 1 is equal to x plus 1 plus IY. Its real part is x plus 2. Okay, so this will become 2x plus 2. Bring all of them balances. We get x square minus y square minus 2x minus 2 equal to 0. X square minus y square minus 2x minus 2 equal to 0. So now P represents z is equal to x plus IY in the R-time plane, and modulus of 3z minus 1 is equal to 3 into modulus of z minus 2. Then the locus of P is mod of 3z minus 1 is equal to 3 into mod of z minus 2. Okay, I take 3 out of this. When it goes out, it becomes modulus of 3. Modulus of 3 is 3 itself. So I can write it as 3 into mod of z minus 1 by 3 is equal to 3 into modulus of z minus 2. 3 gets cancelled, and this mod z minus 2 I am writing here. So together I can write z minus 1 by 3 divided by z minus 2 is equal to 1. So we can compare this with modulus of z minus z1 divided by z minus z2 is equal to 1. I told you that mod of z minus z1 divided by z minus z2 is equal to 1 represents the perpendicular bisector of the line joining z1 and z2. Okay. So now in place of z1 we have 1 by 3. 1 by 3 means it is nothing but 1 by 3 comma 0. And z minus 2, z in place of z2 we have 2. 2 is represented by the complex number 2 comma 0. Okay. So as we know, this represents the perpendicular bisector of the line joining z1 and z2. So this represents the perpendicular bisector of the line joining 1 by 3 and 2. In other words, 1 by 3 comma 0 and 2 comma 0. Okay. So clearly by looking at it, you know that it is the perpendicular bisector, which is a straight line. Now look at the options. So how many of them are straight lines? X is equal to 0. It is nothing but y axis, which is a straight line. And x square plus y square is equal to 3. What does it represent? Yes, it is a circle with center position and the radius root 3. So this cannot be the answer, right? Because it has to be straight line. And y is equal to x. Yes, it is a straight line, maybe the answer. Z 6x equal to 7, it also represents a straight line, may be the answer. Okay, now you observe. One point is 1 by 3 comma 0. So 1 by 3 comma 0 means somewhere here. And 2 comma 0 is here. Okay. One point is here and another point is here. Then I want the perpendicular bisector of AB. That perpendicular bisector will be here. Okay. Which means this is the perpendicular bisector. It is perpendicular to AB and it passes through the midpoint of AB. So we can verify the other three options. X equal to 0. X equal to 0 is nothing but y-axis, right? So y-axis. Perpendicular bisector is here, but y-axis is here. Y-axis cannot be the perpendicular bisector of AB. Therefore, this option is eliminated. Okay. Then what is y is equal to x? Y is equal to x is a straight line whose slope is 1. This is a line y is equal to x. Perpendicular bisector is here, but we are talking about y is equal to x here, right? So y equal to x cannot be the answer. Three options are eliminated. Only one option is left. That has to be the right answer. Okay, that way you can save your time. But now I will explain why that is the right answer, right? So it should pass through the midpoint of these two, and it should be perpendicular to this AB. Okay, perpendicular to AB means this A and B are A and B lie on x-axis. So any line perpendicular to x-axis must be parallel to y-axis. So its slope is not defined. Okay, slope is not defined means you can take that as 1 by 0. Okay, or this line is a vertical line. If it is a vertical line, then its equation must be of the form x is equal to h. I mean, see, you are very well aware of that. Equation of y-axis is x equal to 0. So if I draw a line here, say this distance is 1, then the equation of this is x equal to 1. This is x equal to 2, x equal to 3, x equal to 4, x equal to 5, and so on. And on the other side, x equal to minus 1, x equal to minus 2, x equal to minus 3, x equal to minus 4, x equal to minus 5, etc. Assuming that these are all distances is equal to 1, right? So it's on this side, that means it should be of the form x is equal to some number, right? So look at that equation. From there I can write x is equal to 7 by 6. So obviously that is the answer. But I will tell you how. You take the midpoint of this two. See, I told you this line must be of the form x equal to h because it is parallel to y-axis, and it should pass through the midpoint of AB. What is the midpoint of AB? Find out. Midpoint of AB. 1 by 3 plus 2 divided by 2, 0 plus 0 by 2. That is 0. Right? So this will give you 6 plus 1. 7 by 3 by 2, 0. So that will be 7 by 6, 7 by 6, 0 is this point. Hence the equation is x equal to h. So x is equal to 7 by 6. That way we get the answer. Okay. Let's go to the next question. The amplitude of z minus 2 minus 3i, z minus 2 minus 3i is pi by 4. Then the locus of z is amplitude of z minus 2 minus 3i. Z I write as x plus iy. Then you have x plus iy minus 2 minus 3i. That will give you x minus 2 plus I into y minus 3. X minus 2 plus I into y minus 3. Its amplitude is pi by 4. That's amplitude is pi by 4. Okay. Just observe. Amplitude is the angle made by the line OP with the positive x-axis. OP means P is the point which represents that complex number. Now that amplitude is pi by 4 means it should lie on this line somewhere. Okay. So on this side only, not here. Because if it is here means then the amplitude will be minus 3 pi by 4. Now we are talking about it's here. Amplitude is pi by 4 means we should lie on this line. Do you know what is the equation of this line? The equation of this line is y equal to y is equal to x. Amplitude is pi by 4, so 45 degree. This equation is y is equal to x. Okay? So this x minus 2 plus I into y minus 3 should lie on this. So it should lie on this means its point is x minus 2 y minus 3. It should lie on this. you just observe the points on this line 0, 0, the origin. Then you will have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, etc. You take any point on this line, you will observe that the x coordinate is equal to y coordinate. Because the equation of this line is y is equal to x. Every point on this line will be of the form x comma x. I mean 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Not only integers, you can have 1 by 2, 1 by 2, 1 by 3, 1 by 3, etc. So every point on this line will have x coordinate is equal to y coordinate. So that means you will have x minus 2 is equal to y minus 3. In other words, we bring this side, we get x minus y plus 1 equal to 0. X minus y plus 1 equal to 0, which is the fourth option. X minus y plus 1 equal to 0. Then, let's look at the next question. Modulus of z minus 1 by z minus 3 is equal to 2. Then the locus of z is equal to x plus I y. See here, you can compare this with mod of z minus z1 by z minus z2 is equal to k, when k not equal to 1. When k not equal to 1, when k is equal to 1, it represents the perpendicular bisector. When k is not equal to 1, it represents the circle. We know that this represents a circle. But unfortunately, all the four options what they have given, all of them are circles only. So that shortcut cannot be used now. We have to simplify this. Okay. So from this equation I can write mod z minus 1 is equal to 2 into modulus of z minus 3. I am writing z as x plus iy. So then we can write as x minus 1 plus iy is equal to 2 into x minus 3 plus iy. So this is square root of x minus 1 whole square plus y square is equal to 2 into root of x minus 3 whole square plus y square. Squaring this, we get x minus 1 whole square plus y square is equal to 4 into x minus 3 whole square plus y square. So expand it, x square minus 2x plus 1 plus y square is equal to 4x square plus 4y square plus 36 minus 24x. And after all simplification, this is what you get. Now take all of them to RHS, we get 3x square plus 3y square minus 22x plus 35 equal to this. Okay, 3x square plus 3y square minus 20x plus 35 equal to 0. Option D is the right answer. Look at the next question. The locus of the point z is equal to x plus iy satisfied the equation mod of z minus 1 by z plus 1 equal to 1 is given by z minus 1 by z plus 1 equal to 1. It is the perpendicular bisector of the line joining 1 and minus 1, right? 1 and minus 1 means 1, 0 and minus 1, 0, which is nothing but y-axis. Y-axis, its equation is x equal to z. Let's go to the next question. Look at this. The locus of the point z in the argand plane, for which mod z plus 1 whole square plus mod z minus 1 whole square is equal to 4. Mod z plus 1 whole square plus mod z minus 1 whole square is equal to 4 is a, what does it represent? Is it a straight line, pair of straight lines, circle or parallel? Let us see. Z I will treat as x plus iy. So on simplification it will become x plus 1 plus iy mod whole square plus this will become x minus 1 plus iy whole square. This will be x plus 1 whole square plus y square is equal to x minus 1 whole square plus y square equal to 4. Here a plus b whole square plus a minus b whole square that will give you 2 into a square plus b square. So 2 into x square plus 1 plus 2y square is equal to 4. Okay, I'll divide this equation by 2. That will give you x square plus 1 plus y square is equal to 2. So it becomes x square plus y square equal to 1. X square plus y square is equal to 1. This represents a circle with the center origin and radius 1. So the answer is circle. Okay, now last problem of the day. If argument of 3z minus 2I equal to pi by 2, then the locus of z is equal to x plus iy is argument of 3z minus 2y is equal to pi by 2. Argument is pi by 2. Argument is nothing but the amplitude, which is pi by 2, means that point lies on positive y-axis, right? If a complex number lies on positive y-axis, means its real part must be equal to 0 and imaginary part must be greater than 0. So I am talking about I, 2i, 3i, 4i, 5i, etc. I is represented by 0, 1. Similarly, 2i is represented by 0, 2. So points on this will be of the form 0, 1, 0, 2, 0, 3, 0, 4. And not only integers, you have 0, 1 by 2, 0, 1 by 7, 0, 3 by 8, etc. Okay? So now, argument of this complex number. What is that complex number? 3 into x plus iy minus 2. So 3x plus I into 3y minus 2. Okay? This is a complex number. Its argument is equal to pi by 2 implies that its real part is 0 and the imaginary part is positive. Real part is 0, 3x equal to 0, that will imply that x is equal to 0. And imaginary part is positive, 3y minus 2 should be greater than 0. That means 3y should be greater than 2, y should be greater than 2 by 3. So answer is x is equal to 0 with y greater than 2 by 3. X equal to 0 such that y greater than 2 by 3. Okay, students, with this I will stop today's class. Okay, I have left few questions in between. You try them